continue our discussion of angles. Now, with angles, there is a set pattern on how we name an angle. Okay? Now, to name an angle, let's look at an angle first. Okay? Let's say I have an angle with a vertex of B and two rays, BA and BC. Now, to name this angle, I am going to either start at point A or point C. It does not matter. And I'm going to use an angle symbol. This is just a symbol for the word angle. And it's going to be A. I'm going to travel along the line to B and travel along the line some more to get to C. So the first naming is A, B, C. But remember, we are not prejudiced and we don't have to technically start at point A. We could start at point C, B, and then A. Now I want you to notice that B in both examples of the name was in the middle. And remember, B was our vertex. B was our vertex. Okay? So notice that the vertex is in the middle of our name. Now, another method in which we could name an angle is simply by the vertex. I'm not particularly fond of this method, and you will see soon why. But if we just name this angle, we would name it angle B. And like I said, it's not the best way to name an angle due to the fact that soon there may be more than one angle sharing vertex B. So I wouldn't know which angle I'm talking about if I said angle B. And we'll talk about that more here momentarily. There is another method in which we could just number the angle and call it angle 1. And you can use any number, as you can use any letter. Now let's talk about our relationships. There are several angle relationships that we need to discuss. Angle relationships. Okay. And the first angle relationship we're going to talk about is complementary angles. Complementary angles are angles whose sum is 90 degrees. Angles whose sum is 90 degrees. And you can have two or more. So, for example, have an angle here. And I'm going to call this angle 1 and angle 2, so I know that there are two angles. I'm going to take the sum, angle 1 plus angle 2, and I'm going to say they are 90 degrees. So I know that they are complementary. And you don't necessarily have to have them together, like in this example. You could easily have, let's say, 3 separate angles in which angle 1 plus angle 2 plus angle 3 is equal to 90 degrees. You can have almost any number of angles. It's just as long as their sum is 90 degrees. All right. Given angle 1 and angle 2 are complementary. Find the measure of angle 2. Now, according to the given information, and if it's given, it's always true, 1 and 2 are complementary. So angle 1 plus angle 2 is going to equal 90 degrees. Angle 1 is 3x. Angle 2 is 7x. And we know that they're complementary, so they're going to add to 90 degrees. Combine like terms, 3x and 7x equals 10x equals 90 degrees. Divide by 10, divide by 10, x equals 9. Now, in our example, we're told to find the measure of angle 2. So we know that angle 2 is equal to 7x I'm going to plug in what I found to be x, which is 9. 7 times 9 is 63. And we measure degrees, angles in degrees. Now, the second angle relationship we're going to look at is called a linear pair. Now, a linear pair, there's a pair of them, so there are two angles. And they are formed from a line. Remember, linear usually has something to do with a line. So if I have a line, I officially have two angles formed from a line. Now, so that means the measure of angle 1 plus the measure of angle 2 is going to equal. Now, I want you to recall that if we have a line, it's the same as having a straight angle. And straight angles are equal to 180 degrees. So a linear pair are two angles formed from a straight angle or a line, and measure sum equals 180 degrees. Which brings us to the next concept, which is supplementary angles. And supplementary angles are two or more angles whose sum is 180 degrees. And a linear pair is considered to be supplementary as well. Measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is going to equal 180 degrees. And once again, you can have any number of angles as long as their sum is 180 degrees. And as with complementary, they don't necessarily have to be part of the same angle or line. They can be separate. As long as their sum is 180 degrees, you're good to go. Example. Given angle 1, angle 2, and angle 3 are supplementary. Now, to be supplementary, all three angles, angle 1 plus angle 2 plus angle 3, are going to equal 180 degrees, because we know that they are supplementary. We know angle 1 is 4x, angle 2 is 9x, and angle 3 is 7x. Combine our terms. We're going to get 4 plus 9x to be 13x. 13x plus 7x is going to give us a total of 20x. Divide by 20, and x equals 9. Now we can also find each measure by just plugging in x equals 9. 4 times 9 equals 36. 7 times 9 equals 63. And 9 times 9 equals 81. And if I want to check myself here, since I found all of the angles, I can take 36, 81, and 63, add them together, and they better give me 180. And they do. Now, there is one more relationship, and it is known as vertical angles. Vertical angles are essentially angles opposite from one another, and they are congruent. So if I have 1, 2, 3, and 4 to be opposite one another, if I take angle 2 the opposite angle of is angle 4. So angle 2 and angle 4 are vertical angles. Therefore, they are congruent. So, angle 2 is congruent to angle 4. Likewise, our other pair of angles, angle 1 and angle 3, are vertical angles. So angle 1 and angle 3 are vertical angles, therefore they are congruent. So angle 1 is congruent to angle 3. Now, since vertical angles are congruent, if I have something, two lines that intersect, and I am told that this is 6x plus 10, and this is 50. Now, I know that they are vertical angles, okay, because I can look at my picture and see that they are opposite of one another. And since they are opposite of one another, 6x plus 10 is going to equal 50. I'm going to be told to find x. So I'm going to subtract 10 from both sides. 6x equals 40. Divide by 6. X equals 40 over 6, which can reduce to 20 over 3. And I would just keep your answer as a fraction, unless told otherwise.